Ever wonder how your headphones can take a tiny, tiny whisper of data and turn it into powerful sound? Or how a thermostat uses a minuscule change in temperature to control a whole heating system? Well, the secret is often a tiny electronic component. Today, we're going to go inside the op-amp, what I like to call the signal's super helper.
So, at its heart, an operational amplifier, or just op-amp for short, is basically a super helper for really small electrical signals. You know, think about a signal from a microphone or a sensor. A lot of the time, it's just way too weak to be useful by itself. The op-amp's whole job is to give that signal the muscle it needs to actually do some real work.
But that's where the real magic is, right? It's not just about cranking up the volume. There's this really elegant process going on inside that little chip. So what's really happening inside this super helper to make it all work so well? That's what we're about to find out.
To really get it, we're going to follow a single, tiny electrical signal on its four-step journey right through the op-amp. We're going to trace its path from just a faint whisper all the way to a powerful command. You can actually boil the whole thing down to 4 simple words: listen, boost, adjust, and deliver. This is our roadmap. Pretty much every function inside an op-amp falls into one of these 4 key actions. Let's keep these in mind as we dive in. All right, roadmap in hand, let's get into the step-by-step breakdown. We're going to follow that signal as it hits the very first stage of its journey. The very first thing the op-amp does is it listens. But it's not just listening to everything. It's listening with incredible focus for one very specific piece of information. So this first step, this is the input stage. It actually takes in 2 signals, and its entire job is to find the tiny, tiny difference between them. Any noise that's on both inputs gets ignored. That's a really cool feature called common mode rejection. And it does this with super high input resistance, which means it can listen to the signal without actually messing with it or draining its power.
So you've got these 2 inputs, the non-inverting input, that's the one with the plus sign, and the inverting input with the minus sign. The op-amp is like a detective, carefully comparing these 2 clues to find the exact difference between them. And that difference is the only thing that gets to move on to the next stage.
Okay, let's move on to the second stage and see how this all builds. Once the op-amp has found that tiny difference, its next job is to boost it. Now we're at the intermediate stage, and this is really the muscle of the whole operation. It takes that very small, very precise difference signal that we just found, and it amplifies it. Like a lot. We're talking a massive boost in voltage here, getting it ready for what's coming next. But raw power isn't everything. It has to be refined, right? So the third step is to adjust. This is the level shifting stage, and it's all about precision. The boosted signal, it's not quite ready for the real world yet. This stage is like a master craftsman. It makes one critical adjustment. It shifts the signal's DC level so it's perfectly centered right around 0 volts. This is what makes sure the final output is super clean and symmetrical, with no weird offset.
Okay, our signal has been isolated, it's been boosted, and it's been perfectly adjusted. There's only one thing left to do now: deliver.
And this is the final handoff, the output stage. This part turns that clean voltage signal into a powerful current. Because it has low output resistance, it can drive heavy-duty things, like speakers or motors, without the signal collapsing under the pressure. This is the stage that lets the op-amp actually make things happen out in the real world.
So we've gone from this tiny difference all the way to a powerful, useful signal. But why does this 4-step journey matter so much? What's the real payoff here? The result is pure action. This is where the magic becomes real. That final powerful signal is what's literally pushing the comb in your speakers to make sound. It's what tells a motor how fast it needs to spin. And it's what makes those impossibly small measurements from medical or science sensors big enough for us to actually read and use.
So let's just do a quick recap of the whole journey. It all comes back to our simple roadmap. First, the op-amp has to listen to compare its inputs. Then, it has to boost that difference to make it count. Next, it needs to adjust the signal for perfect quality. And finally, it has to deliver it with enough power to do some real work.
If you take away just one thing from this explainer, let it be this. At its core, an op-amp works in 4 steps. Listen, boost, adjust, deliver.
It's such a simple idea, but it's an incredibly powerful process that makes so much of our modern technology possible.
So, the next time you turn up the volume on your stereo or see a medical device in action, you'll know the secret of that little super helper working away inside. Which brings me to a final question for you. Now that you know their secret, where else do you think these op amps are working silently and perfectly all around you?